I'll just keep going where we left off. So yeah, please check out the questions doc if you have it open on the side. That's where we'll be answering questions as usual. Now I just want to get to some of the feedback that you guys have been giving us. So the structure of this particular recap is to sort of, the point is for us to look at the feedback you've given us and kind of address some of the points. So we hear you that a lot of you have been saying the workshops and lectures are going a bit fast. So we're going to slow down the pace a little bit. Some people have found success from watching the live stream and pausing the video. And then finishing each step before they continue. So maybe that's something you could try. A lot of you say that you feel like you get some of the concepts at a high level, but you aren't able to figure out the stuff when you're doing it yourself. That's to be expected because we're trying to teach you guys how to develop a complete application in just a couple weeks. So no worries after a few short days if you can't do everything already, but that's why we have our 13 dedicated staff members here to figure stuff out with you. So we'll be on the question stock, we'll be on Zoom chat, and we're here to help you during class. Outside of class, we also use our Piazza for communicating, where we've so far averaged a 1-minute response time, which is pretty good. So we challenge you to ask more questions and help us keep that up. A couple other quick announcements. Milestone 0 feedback is out. We graded that and released it last night. So if you have not gotten an email with feedback about your ideas, please make a Piazza post about that and we will address that. Milestone 1 is due tonight at 11:59 p.m. There should be a form linked online somewhere. The Web Lab staff, we can also link it in the questions doc as well. It's due at 11:59 p.m. today. Make sure that you turn that in. It's really fast. This class moves really fast, but that's the exciting part, and that's why we're all here. And to sort of help out even more, we're having virtual office hours today after class online. So if you have any questions from today or from this last week and you feel like you need to catch up, that's what that's for. So we'll be online to help you. Okay, let's jump into the content recap, and then we'll do a Kahoot at the end to review everything for fun. If you have any questions along the way, please ask in the chat, please ask in the questions tab. Okay, so what have we learned so far? In the first 4 days, we've learned 3 completely new programming languages. No sweat. We've learned an entire front-end library, right, which is React. We've started using these things called APIs. And we've also introduced this server thing. So in total, it's no big deal, right? Pretty easy stuff. No, actually, this is a lot of content to cover in just 4 short days. So again, it's okay to be confused, right? We're trying to teach you a lot of stuff and cram it all in. And you may feel like it's all going really fast and over your head. But you may think you're lost, but actually, a lot of these concepts you've already picked up. So be confident in yourself. Let's prove that you already know a few things that are going on. So the first concept, websites use the JavaScript programming language to handle integral logic of the site and to update the variables, right? JavaScript is what sort of controls all the processes. We divide our app into React components to organize the structure of the app. Each of these components is a function, right? That's why we call them functional components. The function inputs are known as props or properties. And they can also store internal private info, such as known as state variables. Right, so properties are the inputs, states are the internal updatable private info. And overall, these functional components return something, right? Functions return things most of the time, and they return HTML-like code. These properties are passed down from the parent components. So they're passed down in the hierarchy from parent components to child components, right? And websites have a front end and a back end where the server lives to handle API calls. So all of these things, maybe they ring a bell. Some of them you might have instantly known, and that's really good stuff. We're making a lot of progress, and now we're going to do an in-depth overview from the start of the class up until now. Okay, so in the first couple days, we started with these web development languages. HTML, which handles the organization and content of the website. We started talking about CSS, which handles the styling of the website and makes everything look nice and pretty. And we talked about JavaScript, which handles the logic and interaction of the site, right? So an analogy that we used in class before, which I'll bring up again just so that we can understand how these are working together at a high level, is a human body. So if your website is like a body, then the HTML is like the bones, which provide structure. The CSS is like the skin, which wraps everything up and makes it look pretty. And the JavaScript would be the internal organs and the muscles and the blood that's moving around and making sure all the processes are happening correctly. Okay, and then on the second day, after going through all that, we hit you with this truck, which was React, right? So there's a lot of questions about React. We're going to spend a significantly higher amount of time going through React stuff and recapping it. If you have any questions along the way, again, please ask in the questions doc and in Zoom chat. We'll help you. Okay, so what is React? React is just a tool for the engineer, the software engineer, or you, right? The person working on the site. It's a tool for you to structure your code, right? That's all that it is. It's a tool for you to structure your code. And what it does is it organizes your code into these trees, these hierarchies, right? Where parent components will have child components that are a part of them. So in the sample application that we've all been building together, which is Caphook React, there's this overarching app component, right, which is handling everything. And then underneath it, there's child components like the feed, the profile, and the navbar. And some of those have their own child components. So it's sort of, it goes down like that. These components are reusable, right? They're modularizable, right? They're reusable, which basically means that we can sort of use them in different places. So if we wanted to have multiple posts, we could reuse the same component multiple times and give it different inputs or different properties, different props. We could reuse it and give it different inputs for it to accomplish the same goal, right? So we could have a post with one type of content. We can have a post from a different person, but all of them are using the same post component to sort of display themselves on the website. Okay, so that's a high level overview of what's going on. Let's dive into some code in specific, right? So this is some code from a very, very simple example React component. A React functional component, right? So let's go through and just walk through and see what each of these lines of code are doing. So up here, we have the function declaration. So just like how in Python, you would do def function name, parentheses with the inputs, and then the colon at the end. Here we're declaring our function. So const example is the name of the functional component, the React component, and it takes in these props or properties as the function input. So we declare our React component as a function. And here at the end, this export thing, which some people have questions about, all that is doing is it's announcing to all of the other React components that exist in the folders or other folders nearby that, hey, I exist, you can use me. So another React component would be able to use the example component here. So that's all that's doing. If I'm going too fast, you can say so and I'll slow down. But is everyone with me so far? Okay, cool. Seems like we're doing okay. Let's move on then. let's focus on this line here. So const state one, set state one equals use state, right? What's this doing? Well, this is just using the React state, right? So we talked about state briefly before. What's going on with this use state function is it's taking an input. In this case, it's one. It can be anything. So it could be a string, it could be an object, it could be nothing at all, right? But it takes in an input, and what it does is it seeds it into the state one variable, right? So when we write this code, this line of code, line 5, we're saying, okay, we're calling use state, we're inputting 1, and it returns a variable, state 1, which is equal to 1. And it also returns a function, set state 1. That function allows us to modify the value of the state. So if we wanted to update the value of state 1, we could call set state 1 of, say, 5, and now the variable state 1 would be equal to 5. So that's what that's doing. It's declaring a state, right? That's the individual private information of the React component. Okay, moving on, let's talk about this. This is the use effect function, right? What this is doing is this is where we get all of the data that we need from the server, or do any of that other initialization stuff that we need. So inside this function, you can do that setup stuff. This code will only run after the first appearance of an instance of this component. Okay, so it's only going to run when you first display this React component. And you can make your API calls from here. Any API calls that you need to set up information for your React component, you can make them in the use effect function line. So we've talked about the state, we've talked about this use effect thing. The last part of your classic React functional component is the return statement, right? So functions have to return something. In this case, our React components are returning HTML-like code for the website to display. And the cool thing here is that you can actually mix in some JavaScript things into your HTML return statement, right? By using these curly brackets. So not only can you return plain HTML text, you can also return specific variable values, right? So we can display the value of the state or use it otherwise to do something. So those are the main parts of your typical React component. Are there any questions before we move on? Feel free to type in the Zoom chat or ask them out loud. Or if there are any good questions from the questions talk, staff can also bring them up. All right, sweet. All right, so that was React in a nutshell. It might have seemed pretty fast, but that's actually most of all there is to it, right? It's when you think of it, it can be really scary, but if you just review it step by step, it should make sense eventually. Let's talk about this other main pain point, which is what is all the server backend stuff that's going on, right? So let's go into that. We have this thing called a server. What is a server? A server, okay, is just a computer. It's another computer that provides a service to the first computer. It's a computer that provides a service to another computer, right? So what you can do is from your computer or the client, you can make requests to your server, and your server can respond to you with data. So if you wanted to access certain data, you could ask the server, hey, can I request you for some data? They say, sure, here's the response. Okay, that's all a server is. So when we do npm run start in our local computers, what we're doing is we're sort of using our own computer as like, we're pretending our own computers, two different computers, and we're using a server from ourselves. But that's a little bit nuanced. You don't have to worry too much about that. Just know that a server is another computer that you can get data from. And actually, a server doesn't have to just serve one client at a time, right? So if you imagine a server at a restaurant, they can wait many tables at the same time. It's sort of the same thing with servers on the internet. So one server, one computer can process requests and respond to multiple clients. So what's the point of the server? Why do we even have it in the first place? Well, first, we need somewhere to get files from, right? Not all of the data that we need will fit on the front end. So we need some of it to be stored on a server in a centralized computer somewhere. Speaking of centralization, we want servers to be centralized so that there's a location where we have centralized data, we have a source of truth, right? So imagine if there was no server, then every pair of clients would need to talk to each other in order to make sure that they're all on the same page. That's a lot more connections, a lot more unnecessary connections that we don't need. As long as everything is connected to a central source of truth, that'll be good. So that's why we have a server. And finally, for security, right? So the code in the server cannot be accessed by any users, whereas other code is vulnerable. So that's why we have servers. They provide security to our websites. So those are the main three reasons that we need to keep in mind. Okay, let's talk about this, how to communicate with servers, right? So we might have briefly mentioned this thing called HTTP. All that is it's a protocol. So it's a method, it's a way for clients to communicate with servers. It's a method for clients to communicate with servers, right? So we do this in two main ways that we talked about. We use GET requests, which are ways to ask for information, and POST requests, which are ways to add new information. There's GET requests to retrieve information, POST requests to add new information somewhere else. You will commonly use this method to interact with your servers, which hosts this thing called an API, right? So let's talk about what exactly an API is. All it is a set of rules. It's like a menu, right? If we want to continue with our server at a restaurant analogy, an API is like a menu. It's a set of rules that we can use. So we can't just order anything, right, from the server. We can only ask for specific things that the server can do. An API outlines those things. They describe how you can access data from that server. And the API endpoints are the various functions that you can call, right? So whenever you're doing a GET request or a POST request, all these request things, all you're doing is you're making a function call across the internet, right? So instead of making a function call within your own code file, you're making a function call across the internet. You're sending your inputs across the internet to your server, and your server's returning your is just responding with the return value of that function. So for example, if I wanted to get a pet by its ID, right? That's like a function, right? I want to input the pet ID and I want it to return the pet. I could do that by utilizing an API. I can communicate across the internet by submitting the pet ID as the input by going to this API endpoint, and it'll return some data about my pet. Okay. So that's what an API is kind of doing. It's a menu. It's a way. It describes how you can access data from the server. Another question that people had was, what's going on with all of this async stuff? Like, what does asynchronous programming mean? Well, JavaScript is an asynchronous programming language. Okay. What that means is that it can run future lines of code before finishing running previous lines of code. Let's sort of get into what exactly the reason for that is. So why might JavaScript want to be an asynchronous programming language? Why might it want to not have to wait for a previous line of code to finish executing? Well, the reason is because sometimes in JavaScript, we're making requests, we're making API requests, right? And remember, that's a function call over the internet. So if I'm making a function call over the internet to a server that's based around the world, say in Australia, right? If I had to make a server call, a function call, an API call to Australia, it might take a whole second for it to get there and come back. And if JavaScript were not asynchronous, that would mean that the entire website would have to wait for that server, for that function call to get back to me, which means that while it's making that function call, I can't click any buttons, I can't type any text, I can't do anything. It can't do any of the other things, which would be bad. So the reason JavaScript is asynchronous is because there are things that we might want to do that we can't wait for. So instead, what we do is we use this .then stuff. This is saying, hey, while you're getting this stuff, getting this pet information like before, you can do things later. And then when you finally figure out what the response is, we can do this stuff in here. We can do this function, this callback function. That's what it's called, right? So if we looked at this code, what do you guys think it would print out? You can either type in the Zoom chat or unmute and answer out loud. What would this code print out? Any guesses? Okay, yeah. So we say unknown. That's going to be correct. So while this GET request is executing, right, it's going to not have an answer immediately because function calls take time over the internet. API calls take time. So while it's waiting for a response, it's going to go ahead and move on to this next line and print the pet name, unknown. And only then is it going to go back after it gets a response and then execute this code and change the pet name to Labrador. So this would log unknown. Okay, so this sort of brings me to the last key point in terminology, which is promises. So a promise is just a guarantee that the unresolved return value from an asynchronous function will eventually become something, right? So here, this GET request is going to return a promise. It's not going to return a value right away. So instead, what it does is it returns a promise. It returns a guarantee that, hey, eventually I will become something intelligible. In order to use the result of a promise, we use this .then syntax, right? So the result of the promise will be the input into the callback function within the .then parentheses. So I'm going to get my pet. It's going to return a promise. That promise is eventually going to resolve into something. So then I'm going to take that something and do something with it in the callback function. So that's what's going on with the promise. And let's just look at some example code, right? So let's say we have this string of code. First, we're going to get this add one API. All it's going to do is it's going to return one more than what we gave it. So let's say I input 5. Then it's going to return a promise, which will eventually resolve to 6, right? So after the promise resolves, then I'm going to take the resolution, which is 6, and I'll do something with it. So let's say I return 6 plus 1, which would be 7. Then I could take that 7 and I can do something with it. Let's say I will log it, so I'll print it out to the console. So that's what's going on there. That's the .then idea. So that's what it looks like. This last part here is a little caveat which is new, which we'll talk about more later. But basically, after your .thens, sometimes you will want a .catch. That'll just catch errors. That'll do your error handling, sort of like exceptions in Python. So that's just a quick review of everything that we've done so far. Coming up today, we're going to do a Kahoot review right now, and then we'll get into databases this afternoon, followed by a lot more exciting things coming up next week. So stay tuned for all of that.
Okay, I'm going to share a screen for a Kahoot. If you're watching from the live stream, please try to hop over to the Zoom if you can, because there's like a delay in between the sharing screen and the live stream. So like it might be like sort of impossible, but yeah. Give me a second. Can everyone see this? Actually, I can't see any people. Okay, great. Oh, there's so many more people on the Zoom now. Okay, I'm gonna start soon. Is everybody joined? Oh, I guess people are still joining. Okay. I'll wait like one more minute or 30 more seconds. Please join quickly. Okay, I'm gonna start. Yeah, why do we have non-yellow answers? Okay, it's fine. I will assume people were trolling. Okay, that was the first easy question. Now I'll actually move on to content review. Nice. Yeah, so basically, props passed downwards from parent to child, from ancestor to child, any way you want to think of it. So if you think of the component tree, like it's just, yeah, passing downwards. So keep that in mind, very important concept. Nice. Yeah, so good job. Most of you guys got it. Basically, that piece of code is actually incorrect. Well, I don't know if I can go back to the picture, but if you remember, like when when you're initializing a state variable, the difference between state variables and regular variables is that if you want to update state variables, you have to use like the actual like function that you used in like the use state line. So remember, there's like constant, and then there's two things in the bracket. The first thing is a state variable, and the second thing is a function that you're using to change the state variable. So you have to use that second thing in the bracket to actually update the state variable. You can't just set it like using an equal sign. Wow, these names. Yeah, so if you remember from Vincent's lecture on Wednesday, question mark, I think Wednesday. So we talked about how set state is actually asynchronous, meaning that it doesn't execute right away. So if you put like a block of code after it, there's actually no guarantee like whether the set state call will finish before the next code block runs. So in this case, we would not have a guarantee on what the console log would print. Yeah, so oh, I guess I don't have the image again. This is so sad. But anyways, the code syntax for that was like a ternary statement, and it's basically just a more compact form of an if statement. So you can think of like, oh, let me type in the chat. I think it was like buka buka not exists, like something like this. So like the first thing is like the thing in the if statement. So if buka buka, and like you don't have to actually write like buka buka is valid. Oh, you can click show media. Where is show media? Ah, oh, very nice. Thank you. Okay, yeah. So it will check if this first statement is valid. And we see here that we initialize buka buka, but we didn't actually assign it a value. So it's currently undefined. So in that case, if the first statement is undefined or null, it will say, okay, this thing is not valid. And then it will go to the second statement. So buka does not exist yet. Whereas if this first thing is true or some sort of like truthy value, then it'll print the first thing right after the question mark. So you can think of this as if buka buka, then like print true exists, else print not exists. Yeah. Okay. Very nice. Yay, very fast answers. Very glad. Yeah, so this is indeed true. State is internal to the component. You're not allowed to modify state from another component unless you're using the workaround that Vincent mentioned, where you pass like a modifying state function as like a prop. And props are external and you can are controlled by the parent of the child, like the parent that passed the prop to the child. So note that there may be multiple correct answers. Yeah, so all of these are actually correct. React components render when the component is first instantiated, when the state changes, because that's how you get the component to re-render. When a parent component re-renders, and when the state of a parent component changes. Yeah. Neopets.com is back with an answer streak of 3. Yay, almost everyone got this. I know some of these were kind of troll. But yeah, if we want stuff to execute after API call or other asynchronous function has completed, then we have to use a .then block. If we put the code right after, right, again, we have no guarantee whether the first statement will complete or not in time. Yeah, so we use post request to send information to the server, and then we want to use a get request to get the retrieve the information back from the server. So these two are like, you can think of them as kind of opposites, where like, for example, if you're going on Facebook and you're making like a post, you're sending content back. And then let's say you refresh your feed. So then you're sending a get request to get all the posts from the server so that you can see them in your feed. But yeah, most people got that. So last question. Yay, almost everyone got this too. Yeah, so the use effect hook is like pretty important. I know like it's probably a little bit hard to understand in the beginning, but like this is basically, you can just think of it as like where you put like cost intensive calculations and API calls and things that you just want to run every time like a state variable changes or every time like the component is initialized and stuff like that. Yeah. So most of you guys did really well. Like I feel like everybody thinks like Dan said, like everybody thinks like, oh, I don't really know what's going on. But in reality, like a lot of these concepts, like we're like repeatedly saying over and over again, and it's like drilling into your head, even though like you're like not completely confident about it. So, but like most of you guys did really well in this Kahoot. So like be more confident, come and ask questions on the question stock or on office hours or Piazza if you're still unsure about certain concepts. And yeah, you guys are all doing really well. And congrats to Maxi, Haha, and Forg, I guess. Okay, that is the end of the Kahoot review session. Thanks for playing.